Greetings to lecturers. So we are from Group 5 will present our OEL about absorption rate of methylene blue on activated carbon. So the first member in this group is Chan Yong Sun, second Edelin Emirra and Empir, third is me, Faradiba binti Ahmad, and the fourth one is Richard Wong Hoong. The first one is problem statement. With the development of industry around the world, the pollution of the environment becomes severe nowadays and cause the water sources to be unsafe to consume directly. Methylene blue has the potential to result in significant adverse impact on both human health and natural environment. Research has demonstrated that activated carbon is a proficient absorbent in eliminating methylene blue from wastewater. The investigation of the optimal condition for eliminating methylene blue utilizing activated carbon, including the absorbent pH and flow rate, remain incomplete. So this experiment aims to determine the most favorable parameter for elimination of methylene blue via activated carbon and to assess the efficiency of the technique in eliminating methylene blue from wastewater. The objective of this experiment are to analyze the properties and characteristics of activated carbon. Next, to investigate the impact of different process parameters on the absorption phenomenon and validate the reported data to diverse absorption isotherm. Next variable. The manipulated variable in this experiment is the pH and the flow rate of the adsorbent, which is the methylene blue. Next constant variable. Contact time, temperature and initial concentration of methylene blue is the constant variable in this experiment. And last but not least is the responding variable, which is the absorption rate of methylene blue utilizing the activated carbon.
For part A, firstly, pour 100 ml of 1 ppm of methylene blue solution into 4 different beakers respectively. Secondly, add hydrochloric acid or sodium hydroxide to vary the pH of 4 adsorbate solution with pH of 1, 4, 7 and 8, 10 respectively. Thirdly, add 0.3 gram of activated carbon into beaker with pH of 1 containing 100 ml of methylene blue solution. Next, place and stir immediately the solution in the beaker with a magnetic stirrer with medium speed at room temperature and set timer for 15 minutes. Fifthly, after 15 minutes, determine the concentration of final solution by using the UV spectrophotometer. 6. Repeat step 3 until step 5 with pH of 4, 7 and 10 respectively. Finally, calculate the absorption capacity with the percentage removal of blue methylene for pH of 1, 4, 7 and 10 respectively using the two equations as you can see below that. For part B, it has the same methodology with the previous slide in part A. The only changes that we made for part B is that the manipulated variable will be the flow rate of the methylene blue solution, which we will vary the mixing time of the adsorbate and the adsorbent. Meanwhile, the constant variable will be the pH of the adsorbate, which will be 4 in this case.
For the pH of adsorbate solution, the data will be tabulated as table shown in this slide. The expected result will be the higher the pH value, the more the percentage of removal of methylene blue. For adsorbate flow rate, we will use 3 different flow rates, which is 5, 10 and 15 ml per minute. Thus, there will be 3 different types of tabulated for time and breakthrough. The expected result will be the breakthrough will increase as the time increase.
So, as shown in the MSDS of methylene blue, the personal precaution, environmental precaution, and precaution on self-handling are to avoid contact with skin and eyes, keep away from drains, surface and groundwater, and avoid dust formation respectively. To control the exposure to hazard of methylene blue, which is harmful, is swallowed, it is a must to wear eye and face protection, hand protection, and respiratory protection. As for the waste treatment method, the disposal of contents and containers should be done in accordance with local, regional, national, and international regulations. While for the MSDS of distilled water, it is important to follow precautions for self-handling described in its MSDS. It is not regarded as dangerous for the environment, and no specific requirements are anticipated under normal conditions of use. Although the hazard statement of distilled water is not classified, it is important to wear hand protection and eye protection. The generation of waste should be minimized or avoided wherever possible. So next, the personal precautions for both MMSDS of hydrochloric acid and sodium hydroxide are: do not breathe vapor, aerosols, and avoid inhalation of dust respectively. Next, as for the environmental precaution, do not let product enter drains. In order to handle both chemicals safely and control the exposure to hazards, it is a must to wear protective clothing or body protection, eye protection and face protection, and respiratory protection. Regarding the waste treatment method, the disposal of waste material should be carried out in accordance with the national and local regulations. Last but not least, both chemicals provide hazards such that they may be corrosive to metals and causes severe skin burns and eye damage. That's all from our presentation. Thank you.